All right, here we go. Now, let's do the same exact problems, only we'll do the flux version of them. That way you're comfortable with the integration and the bounds and everything like that. So let's just try it again, just so you can focus on what the difference is. So this was our first problem here. We've got 2xy dx, that's our p, plus x plus y dy, that's our q. Now, up here, I just put a little note. This is that's our formula, right, for the flux form. So we're going to say that p sub x, this is our p, right? So p sub x looks like that's going to be 2y. And q sub y looks like that's just going to be 1. Then when I integrate, we've got our x values, our y values, so let's set that up. So we'll do the x's first. My default is always to do the x's first unless there's a problem. So 2y plus 1, because now we're adding, right? Dx dy. We're going to integrate this with respect to x now, my friends. So we're going to get 2xy plus x evaluated from 1 to 2. And let's see, so we plug in the 2 first, so that's going to be 4y plus 2 minus, plug in the 1. We're plugging these in for x, by the way, right? So just to make sure I want to make sure that's clear. So we put this together, I get 4y minus 2y is 2y, and 2 minus 1 is 1. Oh, look at that, it's the same. Now, we're going to take that, our 2y plus 1, and we're going to integrate that from, what did I say? 1 to 3, dy. So the integral of 2y is 2y squared over 2 plus y. That whole thing will turn into just y squared plus y, and we'll evaluate that from 3 to 1. So 3 squared is 9 plus 3 minus 1 plus 1. That's what that looks like. This is 12 minus 2, and our final answer is 10. We can move right along since we've got it, and we'll do that second problem that we did. I'm just going to make a note up here. Remember, it's qx plus, did I say qx? Sorry, px plus qy dA. So we're going to go right into our other problem that we did, the same problem. We had y cubed dx minus x cubed y squared dy. So here's my p, y cubed, my cube. Remember, in this case, it's that negative, right? Negative x cubed y squared. And then p sub x. Whoa, 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 whoa. This is just a number, so p sub x is just 0, okay? And q with respect to y, well, it looks like I'm going to be negative 2x cubed y. So when I combine those together, I'm just going to integrate. Remember, my bounds were 0 to 3 on the x and 0 to 5 on the y. Let's bring that negative 2 out. And then we can go ahead and just look at the inner part there. 0 to 3 of x cubed y dx. So I want to integrate that with respect to x. So I'm going to get x to the 4th over 4y. Evaluated from 0 to 3. The 0, again, won't matter, right? The 0 doesn't matter. So we just put the 3 in there. Well, 3 to the 4th power is 81. So this is 81 fourths. So there we are. Remember, I'm dragging this negative 2 along here. Let me just put that up here. That negative 2, we got to multiply that by our super final answer. So now I've got 81 fourths. We're going to integrate that on the y's now, and that's going to go from 0 to 5. Well, that 81 fourths can come out with the negative 2. So it sounds like I'm going to have negative 81 over 2 dy, like that. Integral dy is simply y. So I'm going to evaluate y from 5 to 1 and multiply that by 81 halves. well, 0 is 0, so just put the 5 in there. So I get negative 81 halves times 5, and that looks like negative, what, 2000, let's see, 2025 over 2-ish? Did I do that right? Wrote the 4 out. The 4's cancel. Negative 81 over 2. I think that's right. You guys can check me on that one. There we go.